Welcome back. As I promised, I will be discussing one by one what is in this table. Then the first one there, as you can see, is y is equal to a times the product of x minus p, parentheses, and x minus q in the parentheses. P and q are real. It says here, I have an example here, it says to find the vertex it's always the sum of p and q divided by 2. It is always like that. Okay, the axis of symmetry, and to find the vertex, x value, x coordinate is p plus q divided by 2. Okay, so we expect that if I have this one, if I'm going to graph this one, then if this is my 0, I hope you can see that. If I'm going to sketch that, then I have negative 3. Why? Because if I'm going to put this one, x plus 3, and then x minus 1 is equal to 0, then I have to solve for x. That is negative 3, 1, 2, 3, there, 1, 2, 3, and positive 1 there. Okay? And I have to find the axis of symmetry. Then we have negative 3 plus 1 divided by 2, which is negative 2 divided by 2, which is negative 1. So my p is negative 3, and my q is negative 1. A positive 1, sorry. Because as you can see here, maybe I'm going back here. We have, if I'm going to, my a right now is 1. So if I have x minus negative 3, then you will see that you will get x plus 3. And when I have x minus 1, because I have, it should be negative 3 and positive 1. Yeah. Minus positive 1. Then you will get this part. Okay. So my axis of symmetry, if I will use another pen, is negative 1 here. And the axis of symmetry always divides the left hand side and the right hand side of the parabola. So if from this point to this point, you can see that there is 2, and also from that point. So it's all right. We're doing good. Okay. And then when I know my axis of symmetry, then I also know my vertex, which is negative 1, and then I have f of x is equal to, we have negative 1, negative 1 plus 3, and then we have negative 1 and negative 1. So we have 2 times negative 2, which is negative 4. So we have 1, 2, 3, 4. Here is this. How to find the c or y-intercept when x is equal to 0. So I have f of x is equal to, when x is equal to 0, then I have 0 minus 0 plus 3, and then 0 minus 1, which is negative 3. So it's here. 1, 2, 3. Here, negative 3. So I can sketch this. That is my almost. So if I'm going to use my calculator now, I will show you my calculator. It is like this. Now, it's very similar. What happened if I'm going to, I'm just show you how this changed. If I'm going to put 2 outside and then x plus 3, x minus 1, we'll see what happened. Draw. You see that my vertex axis of symmetry is the same. Maybe I can zoom out so that you can see. Okay, you can see there now. My axis of symmetry is the same. My zeros or my roots are the same, but the vertex and my y-intercept are not the same, but the zeros are the same. Let's see if we can, if I will do that, 0.5 times x plus 3 multiplied by x minus 1. Then we will draw that. See, it opens wider when I will put a smaller number there, because your A will become smaller, and then it opens wider. I can do that also, but it's still the same. My axis of symmetry are the same. Symmetries. No, my axis of symmetry is the same. It doesn't matter, and also my zeros are the same. Okay, the only thing that changes is my y-intercept and my minimum point, my vertex. Okay, let's see if I will put negative 0.25. As you can see there, the same, plus 3, x minus 1. Draw. See? Then it is the same. Okay? So how to do it? I will remove there now. How to do it? How to sketch your graph if you will see this kind of function. Then you need to find your zeros. It's readily available for you, and it doesn't affect your zeros, so you just ignore your A. You just take your factors here, the factors. Okay, so it doesn't matter. It says here is equal to, I can put A, x plus 3, then x minus 1. Then I will have the same zeros or roots, which is what's that? A negative 3 and x sub 1. I will put that way. X sub 1 is equal to negative 3, and x sub 2 is equal to 1. Those are my roots, and it doesn't change. And axis of symmetry doesn't change also, of symmetry, which is x is equal to p plus 2 divided by plus q divided by 2. Okay? Maybe it's not that difficult after you are used to do things. I will give some examples. Here is another example. We're going to sketch this later, but we are going to find the roots first. And we have y is equal to 0. Then we have 2 times 2 x plus 3 and multiply that by x plus 5 in a parenthesis is equal to 0. If we divide both sides of the equation by 2, then we have only x plus 3 multiplied by x plus 5 is equal to 0. And then we have our x plus 3 is equal to 0, x plus 5 is equal to 0. Then our x sub 1 is equal to negative 3, and then our x sub 2 is equal to negative 5 if we solve those equations. Okay, and then the axis of symmetry is always P plus Q divided by 2. And we have negative 3 plus negative 5 divided by 2. Then we have negative 8 divided by 2 is negative 4. So our axis of symmetry is negative 4. And our vertex, we have y is equal to, we have 2 times, we have negative 4. Our x here is negative 4. Negative 4 plus 3. And then we have negative 4 plus 5. Then we have 2 times negative 1 and negative 1, which is 2. Okay, so then our vertex is negative 4 and 2. Negative 4 and 2. No, there's something wrong there. And 1 there. Then we have negative 2. So negative 4 and negative 2. Okay? Then I think we're ready. We're ready to put them in a graph. I think so. Is there anything more that we need? Yeah. Y-intercept. When x is equal to 0, then we have y is equal to 2 times 0 plus 3, and then 0 plus 5. Then we have 15, then we have 30. What? When x is equal to 0. Then we have 2 times negative 4. Yeah. I cannot see why it is wrong. It's 30. Let's see now if we can do that. We have our roots. We have negative 3 and negative 5. I will get a graphing paper here. Negative 3 and negative 5. Then I will put here negative 3 and negative 5. There you go. And then we have, if I remember it right, we have negative 4 and negative 2. Negative 4 and negative 2. There you go. And then we have 30. Oh, sorry. We have 30. Then we can just go up there. But it should look like this. Our line should look like this. In my calculator, it looks like this. 30 is very, very, very long. Okay. So if I'm going to, our intercept is 30. It's way up there. Okay. On my next video, then I will be discussing this one. when it is a square, a perfect square with a outside. See you around.